In a previous video, I shared my experience with the Snapmaker A250T and more specifically, its 3D printing module. Now in that video, I identified that it has an undersized part cooling fan and it also has only a single part cooling fan duct outlet. And that's gonna cause some issues with your 3D printing quality on this machine. So now I addressed those issues by designing some upgrade parts, and in this video, I'm gonna be showing you guys how to install those parts on your A250T as well as A350T, since both those machines should have the same 3D printing module. Let's get started. I've designed two separate part cooling fan upgrades here. We'll begin by taking a look at the first, and the second one with the 4010 fan we'll see later on in the video. And with this first variant, instead of a single part cooling fan outlet, you'll now be upgraded to dual outlets on both sides of the nozzle. It uses the original part cooling fan located on the inside of the 3D printing tool head, and it's a drop-in replacement for the original. If you want to get your hands on one, you can find them on my website, which again is another way to support me and my work, but I'll also make this file available for free with a printables link in the video description down below. Now, if you buy it from my website, as a thank you, I will also include a free spool holder that fits the Snapmaker A250 and A350T. And if you print your own, I would recommend printing it in something with a higher temperature resistance than PLA. To install this thing, we need to begin by removing the left side cover when looking at the print head from the front. If you still have your original Snapmaker screwdriver, you can use the smallest bit in that one to remove these very tiny flathead screws. With the side cover now off, you can see the exposed PCB inside, but we're not going to look at those screws there. We're going to look at the two at the back, and this is holding the PCB in place on a metal bracket. Again, the Snapmaker screwdriver has the appropriate bit for this, and it'll be the 2mm hex bit. Carefully remove these screws and don't lose them. We're going to need them again later. And with those screws removed, now you can gently push on the connector on top and the PCB should pop right out. At this point, you won't be able to pull the control board out very far because a few of the wires are particularly short. The shortest one being the part cooling fan, which is coincidentally what we're after anyways, and it's this one that I'm pulling on right now. So if you're looking at the control board from the front, on the right hand side, it's the second from the bottom there. Next, we have to remove this 4-pin connector on the left-hand side, and this is responsible for the heater cartridge and thermistor, and it's also quite short. Be careful when pulling these connectors out. Try and pull by the connector and not by the wires. These two screws at the back hold the existing part cooling fan and ductwork in place, so we will have to remove those as well. Again, don't lose these screws either. Now, before we can get that ductwork out of the way, we have to move the wiring for the heater cartridge and thermistor. If you look inside the tool head, there should still be a small wiring harness or adapter still connected here, and you can try and push it out, but you'll likely not be able to fit it completely through, and so you can get it part of the way through and then disconnect it at the two connectors there. Carefully swivel those wires up, don't bend them too much, and that small adapter harness can be removed through the side of the tool head. Now you should have enough room to wiggle out the original ductwork along with the part cooling fan, and you may have to gently move those wires aside for the heater cartridge and thermistor. Careful again not to pull on them too tightly. And if you've never taken your print head apart before, now you can see what's responsible for the part cooling, and it's this very tiny little fan. I believe it's only a 25mm fan. And to make matters worse, it seems like they've put this tiny duct on top of the fan, and the intent is to pull cool and fresh air from these vents on the front. However, realistically, there are tons of gaps still between the cover and those vent holes, so it's still pulling hot air, or at least mildly warm air, from the inside of the tool head anyways. In my opinion, then all they've really done here is manage to choke off the fan inlet. It's already a small fan to begin with, and now they've drastically decreased the efficiency of that fan. So we're going to remove that, and we're not going to be reusing it. One important note here is when you're working around this small fan, do not push on the center of that fan. Try not to touch it. Remove the other two screws holding the fan to the original ducts, and then for this first variant, we're going to be reusing this fan. Now we can grab our new dual fan duct, and if you printed your own and you take a close look on the inside, you'll see some support material that I built into the model. If you purchase this part from me, then I will have already removed that material for you. Now we want to remove this material, and I'm just using a hobby knife to do that. If you forget to do this, it's not the end of the world. I put holes in that support material so that in the event that you do forget to do this, it'll still function probably just fine, but by removing that material, it will increase the flow. Use a knife or some needle nose pliers to pick away at that material and just make sure nothing is left floating around in those fan ducts. Now we can grab the original part cooling fan, make sure that the wiring is facing in this direction here, and then we can reuse the original hardware and fix the fan in place. When you're done, it should look like this, and remember that we are not reusing that inlet shroud on top of the original fan. Installation is just the reverse of the disassembly, and so you should be able to carefully maneuver the new part in place. Do not aggressively push or pull on those heater cartridge or thermistor wires, although right now you will have to flex them and bend them a little bit to try and get them back inside of the housing. If you have big hands, this might be a little tricky, but we do have to get this harness reconnected. So to do that, I'm going to, like I said, carefully push that connector back in place. And then rather than pushing and pulling on wires, what I can do here is I can grab my screwdriver and I can use one of the blunt edges of the hex bits, and I can push on the back of the plastic connector to help me push those two connectors back together again. I'm not pushing on the wires. It should snap back together, and then it should look something like this, and then you can reconnect that connector back onto the control board. Next is the fan connector, and it's slightly shorter, so it's a little trickier to get your fingers around, but you should be able to get that back in with pretty minimal effort. Then you can maneuver the control board so that the main plug sits back inside the pocket at the top of the tool head. And then we can look at the back of our tool head, and we're going to be replacing those two screws that hold the fan duct in place. Line up the holes in the fan duct with the holes in the tool head body, and then reuse the original screws, and they should thread themselves into the plastic. When you're finished, take a look at the position of the ductwork with respect to the nozzle, and the nozzle should be sitting below that ductwork. It is pretty close. I left about 2 to 3 millimeters of a gap, and so it should never hit any of your prints. Now we can put the two flathead screws holding the control board back in place, and as with all of the screws, do not over tighten them. This is pretty small hardware. The side cover is the last piece to go back on, and then you'll have your tool head completely reassembled. Now we can take a look at the effect of using the dual duct adapter. I've printed a total of 8 calibration cubes. The grouping of 4 on the left is before the dual duct, and the grouping on the right is after the dual duct. I didn't change any G-code for the matching pairs, and this first set was printed in the regular calibration cube XYZ orientation. These are printed at 0.2 millimeter layer height, and I printed them at speeds faster than what the presets come with in the Lubin slicer. In this case, what I noticed is that the flat faces look a little better on the dual duct, but where you really see the difference is on the Y side of the cube. On the single duct version, the Y side of the cube faces away from the single part cooling duct. On the single duct version, the surface is kind of wavy and you can see a loss of detail in the middle of that Y. On the dual duct version on the right hand side, it's extremely sharp. And that's because we now have that second duct facing the Y side of the cube. In the second set of cubes, we're likely going to see a similar result because I printed these at a slightly slower speed, so this is pretty much the standard fast preset setting within the Lubin slicer. The cubes are printed in the default orientation, and you can see again the surfaces here are pretty comparable, except again for when it comes to the Y faces. The reason for printing slower at this preset speed was to prove that this problem exists even with one of the default settings. In my opinion, this is a problem that shouldn't exist on default settings, yet it does. But at least we know how to solve it. This next set of cubes was printed at a 45-degree angle, and the reason I did this was to see if this would make a difference in the print quality for the original single duct. And to my disappointment, it didn't really seem to make that much of a difference with the single duct. And this sort of makes sense because even at a 45-degree angle, that Y face is really still not facing that single duct. The dual duct version looks a lot sharper, especially around all the details of that letter Y. Now the other benefit, which I sort of failed to point out on some of the other cubes, was the corners of the cubes themselves. On this 45-degree angle print, it's not quite as obvious, but on some of the other prints, the cube corners turned out quite a bit sharper on the dual duct. And now finally, just to really drive the point home, what I did here was I mirrored these parts. So these parts now have the Y face on the opposite side. So on the single duct version, the Y face is now facing the single duct of the part cooling. And so if what I'm saying here is true, we'll see that on the Y side of the cube, again on the left-hand side with the single duct, the Y will now appear very sharp. And take a look at that, it does. But it also does on the dual duct version on the right hand side, and that's the whole point. The dual duct version gives you even part cooling no matter what the orientation. The first variant I just showed you will give you better part quality with the original part cooling fan equipment, but it can only do that at the original default print speeds, maybe a little faster at best. Since the original part cooling fan is undersized for this fairly modest hot end, I figured why not upgrade to a 4010 radial fan. The new parts will interface with the dual duct adapter that I just showed you, and this should be a better match for the throughput of this hot end. Getting this extra equipment installed is pretty easy. In the first part of this video, I showed you guys how to disassemble the 3D printing tool head to the point where you could remove the original ductwork and the original part cooling fan. To install the 4010 part cooling fan version, we need to get back to this point here, so you can go back to the beginning of this video and watch that disassembly portion. The difference in this assembly begins here, where we need to flip open the cover and we need to loosen off the set screw on the side of the heatsink. And this is going to release the nozzle and the heater block so that we have more room to work with. One of the bits from your Snapmaker screwdriver will fit. You don't have to completely remove that set screw, you can just loosen it off and then you'll find that the hot end, heat break, and nozzle will pull right out. Now we can grab our new dual nozzle fan duct, and if you guys haven't watched the first portion of this video, you can go back and check out the part where I tell you about removing the support material from the inside. As with the other version, if you bought this part from me, you don't have to worry about that because I've done this for you. This intermediate tube will get installed on top of the dual duct adapter and it will go directly in place where the original part cooling fan used to be. It uses the original hardware, and in this case we're only going to need 2 of these screws instead of all 4. These original screws are thread forming screws, so they will cut their own threads right into the plastic. Now we need to carefully maneuver this assembly into the body of the 3D printing tool head. It will take a little bit of wiggling, but it should fall into place without too much effort. Then we can push our heater block and nozzle back into place, make sure it's completely bottomed out into the heatsink, and make sure that your heater block is aligned properly. It does have a protective silicone boot, but we still don't want it touching the plastic parts. And just a friendly reminder, when you are tightening down the set screw, do not overdo it. It is threaded into the aluminum heatsink and you could easily strip threads in aluminum. After you finish tightening it, double check that your heater block is straight and it's not touching any of the plastic parts, and then you can shut that cover. With the ductwork still loose, we now need to get this 4-pin connector for the heater cartridge and thermistor fed back into the main body and connected to that small harness. Be careful not to damage these wires as you're manipulating them. Do not push or pull on them too aggressively. Once you get the connector back inside of the housing, try your best to push on the connectors, and again, don't push or pull too hard on the wires themselves to get those connectors back in place. I like to use the blunt end of the hex bit to push on the white connector body, not the wires. Now we can secure the ductwork assembly in place with the original 2 screws that go into the back of the 3D printing toolhead body. Now it should look something like this with both screws in place, and if you take a look, the nozzle should be sitting below the ductwork. Now you need to find yourself a 4010 radial fan. It has to be a 24 volt version, and on the end you're going to need a JST XH connector. Luckily, this is a super common part for 3D printers, and so you shouldn't have a problem finding one. The only thing you may have to do is shorten the wires a little bit, and we're going to make sure that the pins are in the correct place. So the original part cooling fan was oriented like this, and you can see where the red wire goes, the red wire being positive, and that's 24 volts. You can even see on the PCB, it's printed right on there, 24 volts. My new fan uses blue and yellow wires, but I've verified that the yellow wire is positive, and so when the connector is in the proper orientation, I'm getting 24 volts to the proper wire, so we're good here. And if you guys want to see how I use an inexpensive tool to crimp these JST connectors, which are very common on 3D printers, check out the link in the top right-hand corner of the video right now. Now we can take that new connector and fish it through the side of this new plate. There's a large opening that it should fit through, and make sure that the outlet of your fan is pointing down inside of the duct. And then included in the kit, if you bought it from me, you'll find these M2x8 thread forming screws. They'll have a Phillips head on the end, and the original Snapmaker screwdriver conveniently has a Phillips bit. Go ahead and tighten all 4 screws down. And when you're done, the assembly should look like this. Now we can go back and finish the rest of the assembly by connecting the 4-pin connector to the control board. And we're going to take our new fan assembly and we're going to plug the new 4010 fan into the original connector. The main control board then gets pushed back into place and the connector on top sits inside of that pocket. Then we'll reinstall the original 2 screws holding the control board in place. And if you've done everything correctly, you'll notice that that intermediate duct is sitting up a little bit proud of the end of the main body, and that's going to sit inside of that hole inside of your new cover. And now using the original M2 flathead screws, we can secure the new cover in place. The new cover is plastic and no longer metal, so do not go too crazy with the torque on these small screws. The final assembly will look like this, and now we can check out some test prints. First, we can have a look at this overhang test. And you can clearly see that it was doing fairly fine up to about 50 degrees. 60 degrees is where things started to turn a little bit messier, especially on the backside, and then it seemed to catch beyond that at 70 to 80 degrees, and those are pretty extreme overhangs, and the print was at least able to complete itself. Truthfully, I've seen better on other machines, but on the A250T, this is a lot better than what I used to get, even at 45-degree overhangs with the original single duct and smaller fan. At the point where you're doing 60-degree overhangs or more, I would consider using support anyways. Next, I printed this Darth Vader head, and it needs to be printed in such a way that it's more or less completely sitting on top of support material. The thin-walled support material does tend to need very good part cooling so that it remains stable through the entire print, and this Vader head went off without a hitch. This was done at 0.2 millimeter layer height, and the layer lines are extremely smooth and the details are very sharp. The only part that's a little rough is on the very bottom where it was making contact with some of the support material. But it's not just about the way the part looks in this particular case, it's also about how I was able to increase the print speeds and still achieve this level of quality. Now, I'm not trying to mislead you and make you think that we're in Bamboo Labs speed territory, but this was a big improvement over the original Snapmaker settings, and so I set most of the speeds to about 75 to 80 millimeters per second, and the exterior perimeters were slightly slower at about 65 millimeters per second. Now, likely with the small print movements, we may not have been seeing those actual speeds, but I'm still convinced that this part has turned out quite a bit nicer than it would have without the 4010 cooling fan. I'll be continuing to experiment with faster speeds, more severe overhangs, and longer bridges with this new fan setup. It's looking very promising, and so if you're looking to get one of these for yourself, check out my website, embracemaking.com. I'll put a link in the video description down below. If you visit my website, you'll see that I have more than just fan ducts for sale, and if you watched my previous video on my review of the 3D printing module of the Snapmaker A250, you'll see that I had an issue with the flex plate. I had several prints that just got way too stuck to the build plate. I had to pick and scrape this thing off with a razor blade, which isn't the safest thing, and it's also very tedious and frustrating. Additionally, I ended up causing some minor damage to the flex plate itself. Now, luckily there is a better alternative, and that is a PEI coated flex plate. PEI will stick just as well when it's hot, but when the flex plate cools down, it releases parts much easier than these PC coated flex plates. Also, what's great about some of these PEI coated flex plates is that they are double-sided. At least the ones that I sell on my website, embracemaking.com. One side is smooth and one side is textured, so it's kind of like you get two plates in one. Now, I do prefer PLA on the smooth side, and I tend to print PETG on the textured side. The textured side will transfer that pattern to your part, and I think it looks really nice. So if you want to get one of these flex plates for yourself and at the same time support my work, head on over to my website, embracemaking.com. I can get them custom made in any size, and so if you don't see your application, feel free to shoot me a message. That's it for this video. Thank you guys so much for watching, and be sure to check the links in the video description down below if you haven't already.